DHCP, Dynamic Host Control Protocol. So we can configure DHCP in Cisco routers, then Cisco router will offer dynamic IP address assessment to all DHCP clients. So what DHCP will do? DHCP provides. It is used for dynamic IP address assignment to the network devices, network host. So DHCP server provides IP address, subnet mask, default gateway, and DNS server IP address to DHCP clients. In simple example, this is your internet router, Wi-Fi router. General example I'm telling is, this is your D-Link router at your homes, right? So for this router, we got ISP connection. So that ISP connection, on which port of the router we used to connect? D-Link router in the backside, we have a 5 ports is there. And which port do you use to connect your ISP router? ISP link. The backside of your home routers, have you seen four ports are normal? The one is in the different color will come, blue or yellow, right? So that port is a WAN port. The ISP is connected to WAN port or internet port. The remaining devices are connected to LAN ports. It can be wired or it can be wireless. This is your mobile phone. And is your laptop. So these devices are connected. Like how to connect your device to Wi-Fi? What is the process generally we use, guys? We just create a SSID name and password. So we switch on your Wi-Fi here, in your laptop also, and we entered name and password. That's it, right? And your D-Link is being connected to your devices, your mobile phone or laptop. And we'll get internet. But how the traffic will move from your PC means your devices should require IP address, subnet mask, default gateway, and DNS server, DNS IP address, you know. So do you assign these IP addresses for your mobile phone manually? No, we don't assign. So do you assign this IP address, subnet mask, these things to your laptop manually? I'm asking about general point. No, we just entered your Wi-Fi password and we are pairing to your device. That's it. So once the device is being paired in the D-Link router, which is by default DHCP is being enabled. So this DHCP is going to offering you. That's the point of here. Can write it. It is used for dynamic IP address assessment to network devices and host. So these are the host. So your D-Link router is providing automatic IP address and passwords, IP address, subnet mask, and gateways, and DNS IP address, all the things. So that is by default is enabled in all your home routers, DHCP. But how we can configure DHCP in a Cisco routers? That is the main point. So DHCP server provides IP address, subnet mask, gateway, and DNS server IP address to DHCP clients. So let me design one topology here. End user 1, 2, 3, 4 users. This normal configuration I'm doing on router. Enable config terminal, host name, HYD, interface. Manually, I'm assigning IP address. Ethernet 0/0. IP address 10.0001.25.0.0. No shutdown. So what is the network design you have designed here? Router, switch, user 1, user 2, and router host name is Hyderabad. And fast Ethernet I have assigned 10.0.0.1/8 IP address. So basic fundamental rule is what? Router LAN interface and user should be in the same network. So these IP address manually we can assign, but in real time, all the employees, all the users will get automatic IP address. Means we need to be configure DHCP router. Then router will provide automatic IP address to all the clients. In this 10 network, in this /8 subnet, that's something we need to be configured now. Like IP DHCP pool, we have to create the pool with any name. Using name is a CCNA. So IP DHCP pool name is CCNA. Now we can write network and which network do you require? IP address and which subnet it should be there. 255. And what will be the gateway address? 10.1 is the gateway, right? Then you can use default router 10.0.0.1. Default gateway is also okay. If you have a local DNS, any DNS servers in your office, you can use the DNS server. Or you can use global DNS server. DNS server 8.8.8. That's it. Now, if we check IP address to DHCP clients, yeah, client 1, first user, desktop, IP configuration. If we click on DHCP option, requesting IP address, 10.2. So I got DHCP request is successful and I have received 10.2 is IP address, subnet mask, gateway, and DNS server IP address automatically. Dynamically, I got it. Now for second computer, same. Click on DHCP. Yeah, request success. Now we got IP address. Next device, 10.4. 10.5, like this. It's clear?
What if there are a number of routers in between?
Yeah, and which router you have configured DHCP, the router will offer you.
Meaning in the network, only one router will be the DHCP router, right?
Yes.
So how you define that meaning to the other router to pick the DHCP from this router?
See, initially, why we require the multiple routers in your LAN? Multiple gateways.
I have one in the same example, one in Hyderabad, one in Bangalore, one in Chennai.
Okay.
So if my Hyderabad office is the DHCP server, how about
Mm.
my Bangalore office and Chennai office? They will depend on the DHCP from this Hyderabad server, or they will
Yeah.
locally pick it up.
So R1 is in one location, one site. In R2. So R2 is in a network of 192 network. Now R2 LAN user also required automatic DHCP IP address. Here we can configure DHCP or else R1 itself we have configured only DHCP here. So I'm not running in DHCP in R2. So my DHCP server is R1. Now R1 will provide IP address to R2 LAN also. Then R1 will provide DHCPs for R1 LAN also. It's providing a DHCP for R1 LAN users and R2 LAN users. So in R1, we need to create two DHCP pools. Pool 1 for R1 LAN users, pool 2 for R2 LAN users. The thing is, in R1 and R2, routing should be enabled. Communication should be enabled. Then here if we configure DHCP pool 1, DHCP pool 2, then one pool for LAN, local LAN, and another for R2 LAN. One more for R3 LAN, like this. Okay.
Thank you.
So in our example, we have enabled DHCP in R1 LAN only, and R1 is providing IP address to LAN users. So what is the first LAN user IP address? We got 10.2, it's 10.3, 10.4, 10.5 like this. Now for first computer, 10.2 IP address will be how long it will be the 10.2 IP address? Today I got 10.2, like how long the same IP will be for the spacing? 1 hour, 2 hours, or 6 hours, or 1 day. Like after my 1 hour, my PC is being restarted, and maybe 5 minutes. After 5 minutes, my PC is restarted. What IP will get? Same IP in the different IP. It depends upon the DHCP lease time. DHCP lease. So every DHCP servers has a default some lease timers. If it's a Windows DHCP server, by default lease time is a 8 days. Same IP will be the 8 days. But we have configured DHCP in Cisco router. So Cisco router is 24 hours. Anyhow, we can configure, we can set the lease time manually. Default lease 24 hours. So you want to make the number of days, lease space 20, 10, 5. 20 days, 10 hours, 5 minutes. So lease space, 3 values. The first value is days, second value is hours and minutes. I want to configure only minutes, make them into 0 days, 0 hours, 32 minutes. Like we can set the lease time. If we don't give the lease time command, IP will be 24 hours. So in the packet tracer, the lease time will be not work. Lease something 5 days, 4 hours, 3 minutes. Or you can do one thing. Lease days, hours, minutes you can write. Is the syntax of the lease configuration. So lease space if is a question mark. So it is not allowing here. Lease command in the packet tracer. but it will work the same. Okay. Now let me check for my computer. What is my computer IP address? IP config. Yeah, Ethernet. IPv4 address 192.168.0.4. So my home router is given me like 0.4 is IP address. So this 0.4 IP address will be how long for this computer? When this IP address is obtained, when this IP address is going to expire, like how we can check that? Same command prompt, the same command, ipconfig /all command if you use, then we'll get the information. Lease obtained Thursday, April 22nd, 12:21. Lease expires when? Friday. Like today, April 23, 2021, 9:45 a.m. So after 9:45 a.m., I'll get maybe the same IP or the renew IP address will get actually. So these two options we can see, lease when obtained and when expired. Okay. Now DHCP is assigning IP address to DHCP clients in, yeah, Shivaji, please. Shivateja. Any doubts?
Yes, sir.
Yeah, please.
So we have obtained DHCP for the network 10.0.
Yeah.
But we don't, in this we don't need any subnetting for decreasing the wastage of IP addresses.
What is the subnet mask you have assigned for your router fast Ethernet? In the subnet will be provide IP address.
Okay.
So in router, I have assigned the subnet mask is default subnet mask 25500. So you want to make them into customized, you can configure the subnet mask what you have customized subnet mask. Then the router will allows that IP address ranges only. Okay.
Okay.
Yeah. So DHCP is assigning IP address in the sequencing like 10.2, 10.3, 10.4, 10.5, 6, 7 like this. But what if your requirement is some IP address you want to reserve for static, like manually want to use some IP address in the LAN. So that IP addresses we can exclude it from this range. The range of IP addresses we can be excluded from the DHCP pool. Example 10.2 should not be used in my LAN automatically, dynamic. So 10.3, 10.4, 10.5 up to 10.30 IP addresses DHCP should not use. Then what we'll do? We'll write the range, excluded range here. IP DHCP excluded address range 10.0.0.0.2 space 10.0.0.0.30. The IP address has been excluded. Now DHCP will never make use this 10.2 to 10.30 IP addresses. Now DHCP will start assigning from 10.31. Because of this, IP address has been reserved. Now let me check. Practically, for first computer, click on DHCP, requesting IP address. See now I got 10.0.0.31 IP address. Second computer, 10.0.32. Like this, we can reserve some IP addresses from DHCP pool. Okay.
Balu, how is it configured in Zoom, Balu? Is the Windows server giving the DHCP or Cisco routers?
Where?
In your office?
No, we have configured Cisco routers, DHCP.
Usually in the real world, is it Cisco who is providing, or it will be the Windows who provides the
No, you are
DHCP?
maintaining the Windows servers in your LAN, then we'll configure Windows actually, no? Windows. See, the infrastructure what you have, the requirement of your LAN is more, system administration work will be more, and they are maintaining the Windows 2016 server or Linux servers. So you have created the work domain, work group models. So more Windows administration work will be there. Then you can go for the Windows DHCP. So what we have in my office, like we don't have any like domains, like any Windows servers actually. And we used DHCP, Cisco router department wise on the internet. So we have configured DHCP and Cisco device.
Okay.
Yeah. So next point is router can be configured both as DHCP server and DHCP client. So till now we have discussed how router offering DHCP IP address to DHCP clients. Then how router will receive the DHCP IP. So router can be configured both as DHCP server and client. So how it be client is very simple and small example. If you take your home routers, you are getting IP, you are getting a internet connection from ISP to your router WAN port, right? Yes. Now, are you assigning manually IP address to your WAN port? No, because we don't know what IP is giving by ISP. So what is the configuration we do in your home routers? We used to create just SSID names and your password. That's it, right? That's it. The remaining everything is been pre-configured, means your default routing is pre-configured, NATing is configured, ACL is configured, and DHCP is also configured. So what type of DHCP means? Now DHCP is ISP router. ISP is DHCP server, is providing IP address to a D-Link router WAN port. Your WAN port is receiving IP address from ISP. Means your office, your home router WAN port is DHCP client. So the interface which is receiving the DHCP, that interface is the DHCP client. The interface which is offering the IP address, that is the DHCP server. So router WAN port is DHCP client, and your LAN. In LAN we have assigned 10.0.0 network. So your LAN interface offering IP address in the standard network to your LAN users. So your LAN interface is DHCP server. So the router can be configured both as server and client. Simple. Router WAN ports are clients and LAN port is server. Let's see how to receive DHCP client IP address. I'm using a router in LAN. Generally, what is IP address configuration? Interface fast Ethernet 0/0 or 0/1, whatever. IP address 192.168.1.1 255.255.255.0. No shutdown. This command is configure. This is statically. Manually, I have assigned IP address. Then how we can get automatic IP address? Same configuration, fast Ethernet 0/0, IP address, DHCP, no shutdown. This is client configuration, DHCP client configuration. Now fast Ethernet 00 will receive IP address from LAN, DHCP server. Show IP interface brief. Show IP. If we get IP address, we'll get the log message. Just wait for a few seconds. Yeah. Now we got IP address. See 10.0.0.33.192.168 out of 2 IP address, which is DHCP is offered, which is manually assigned. It's clearly showing here. Method is DHCP 10.003, manual 192.168. Okay.
So can you explain in 1 second?
No, how to receive DHCP client configuration is normally we used to configure IP address. This is the command, right? 192.168.2.1 subnet mask and no shutdown. This is manually we have configured, but I want automatic IP address. Then you can use IP space address space DHCP and no shutdown. That's it. Now we'll get IP address automatically. So fast Ethernet 00, DHCP is assigned. 01 manually I have assigned. Like this. Okay. So this is a DHCP server configuration and client configuration. Any doubts? So what is the topic yesterday we have discussed?
NATing.
Default routing.
Default routing.
Default routing and NATing. Service is okay, leave it about default routing and NATing, right? Yeah. So this is R1 and fast Ethernet. IP I have assigned 10.0.0.1/8. Serial which is connected to ISP. Tell me one service provider name. One service provider name, please. Yeah.
Geo.
Okay. Broadband services. So have contact to Airtel or Geo, whatever. BSNL, any Act Fiber also. And it is connected to internet. And internet link speed, I have used 80 Mbps link. Now what configuration must be there in your router LAN users to reach internet? Your LAN users, like all LAN users, how they can reach internet? What configuration must be available in your router, Cisco router?
Default routing and not configured.
Very good, Sai Krishna. So default routing is must be there, and NAT methods, PAT, NAT, whatever, NATing configurations. So NAT will translate private traffic to public and public traffic to private. And default routing is forward traffic to reach unknown destinations. These are mandatory, must be configured actually. Okay, I have enabled default routing, NATing, ACL, DHCP, everything is okay now. Up and running my network. Now LAN users are reaching internet with 80 Mbps link speed in ISP is Airtel. Now the main point is what after some time if your ISP fails. If ISP fails, users can reach internet? No. So here, single point of failure means if ISP is down, no internet access. So complete your LAN user depending on that ISP only. If it's down, no internet. So to eliminate single point of failure, backup is required. Redundancy is required. So what I'm doing is I'm taking one more link from service provider for backup. ISP 2. This is ISP 1. See for ISP 2, if we use again Airtel from Airtel, if ISP 1 fails, then automatically ISP 2 also will be down. The chances, right? So when you are taking the redundancy backup, better to go with a different service provider. BSNL. So R1 is serial 0/1. Connect to internet. Why ISP2 is required? Yes.
For a backup, sir.
For backup purpose, then I'm not going to take again the 80 Mbps. Is only for temporary alternate backup only. Na? This is my primary link, 80 Mbps. So I'm using here just 40 Mbps link. Okay. Yeah. Now we have redundancy. So we have redundancy for what? So we have redundancy for ISPs. If ISP 1 is down, ISP 2 is available. So without any delay, users can reach internet, can access the resource of internet. Even if your event 1 link failed, ISP 1 down, then immediately they can go via ISP 2. So the good thing is here, redundancy for ISPs. ISP 1 is okay, ISP 2 is okay. What if my gateway is down, router is failed? Again problem. If router is down, then no default routing, no NATing, no gateway, no ACL, then how can reach internet? So we are making sure ISP redundancy, but we don't have here router redundancy. Gateway redundancy is not there. Hello, if you're getting my point?
Yes, sir.
Yeah. So what we do in the real time means we need a gateway redundancy also. We have to use multiple routers in the LAN. If one router is down, then immediately traffic has to redirect to second router. Right? Yeah. So let me design gateway redundancy topology. So two routers, R1, R2. R1 is connected to ISPs. As for example, ISP1 80 Mbps link, ISP2 40 Mbps link. All service providers, ISP1, ISP2, like all service providers are connected to internet. And LAN users, R1 LAN port, R2 LAN port are connected to switch and switch to end user. So in our LAN, we have two routers is there, R1 and R2. Why two routers is required? Yes, please. Why two routers is required?
Backup.
Yeah, backup. Redundancy purpose, no? Yes. So if router 1 fails, then users can reach with internet with router 2. If router 1 up, we'll go with the router 1. So backup is there. Without any no downtime, users can reach internet. Is a good, right? But the main point is here, we are facing very big problem here when we have the multiple routers. So the good thing is backup is there, redundancy is there, R1 fails, R2. But again, we have some problem is there. You know what is the problem is? R1 LAN interface IP address 10.0.0.1. R2 LAN interface 10.0.0.2. So as per the basic network fundamental is what? Router LAN IP, end user's IP should be in same network. 10.3, 10.4. Then what will be the default gateway address? Yes. What will be the default gateway address, please? Default gateway for LAN users is 10.0.0.1 or 10.0.0.2. So if I assign default gateway is 10.0.0.1, then all the LAN users traffic will come to R1, ISP1 internet with 80 Mbps, we can get internet. That's good. Okay. The what R1 fails, then users can reach internet? No. Until unless we have to be change the gateway address. Now I have to change default gateway is 10.2. If we change the default gateway 10.2 for all LAN users, now traffic will be directed to router 2, ISP to internet with 40 Mbps speed. You can get internet. Now again, after some time, your R1 is okay now. Then how the traffic can reach 80 Mbps? Again, change the default gateways 10.1. Again, if router 1 fails, again change the gateways 10.2. So this is the problem when we have the multiple gateways in your LAN.
Sir?
Yeah,
Hello.
yeah.
Sir, this gateway it's manually changing the IP address when
Manually,
R1.
yes.
Okay. Hello. Hello.
Yeah, please.
Yeah, so in this case, can we use DHCP here?
In this case, DHCP will not work here.
Okay. So we have to manually always change the.
Yes. So there is a problem here actually. Manually, again, if router 1 down, again you have to configure router gateway have to be changed. Again, router 1 active, again have to change. This is the problem. But in this above topology, we don't have problem. Why? Only one router. Router gateway have assigned. So traffic will go. The point is what here? Single point of failure. Router 1 down, no internet. See, a problem is single point of failure. No gateway issues. But here is what redundancy is available, but gateway issue is there. So in real time, we use this topology, and to manage your gateways, we have some protocols. So we have some protocols. That protocols are FHRP protocol, first hop redundancy protocol. So first hop redundancy protocols are group of protocols which provide default gateway redundancy. First hop redundancy protocol. What this protocol will do? FHRP are a group of protocol that provide default gateway redundancy if there is more than one path to the same destination. So these are the protocols. Following our HRP is what? HSRP, VRRP, GLBP. These all protocol will be managed this gateway issue problem. So we have about HSRP protocol in our sessions. We'll see about HSRP. HSRP is hot standby router protocol. The first thing about HSRP is a Cisco protocol. HSRP is what? Cisco proprietary protocol. Now, how this HSRP is going to manage your gateway issue? If you have a two gateways, problem is there. 10.1, 10.2 have to be changed. Then what HSRP is doing is, no, you are not two routers, you belongs to only one router. It's grouped together multiple physical routers into one virtual router. HSRP groups multiple physical gateways, multiple physical routers into one virtual.
It's
Means
called
totally have
clustering.
a two route. Yeah.
Is it clustering?
Similarly, not exactly. So it's just router 1, router 2, you are not two routers, you belongs to only one router, one virtual router. Is acting like one virtual router. So both is belongs to what? One virtual router actually. HSRP, virtual router, IP address. Let's say let me configure IP address. Virtual router IP. See, R1 physical interface IP, R2 physical interface IP, and virtual router IP address 3 should be in the same network. 10.0.0.123 is example. Okay. Now this information, HSRP virtual IP address is 10.0.0.123. That information need to be configured in R1. R1, your physical IP is 10.1 and virtual IP is 10.0.0.123. So R1 virtual IP information is available in R1 router. In R2 also virtual router IP is what? 123. So R1 maintains the virtual IP. R2 maintains also virtual IP now. So for all the LAN users, instead of assigning physical interface I as a gateway address 10.1 or 10.2, now gateway address is 10.123, which is virtual router IP. For all the LAN users, gateway is 10.123. Now we need to be change the gateway always now. So 10.123 is gateway, that's it. Then how traffic can reach internet? So traffic will reach internet with R1 router or R2 router.
It will be configurable, maybe.
Okay, of course we can configure. But generally, how traffic can reach to internet with R1 and R2? See, R1 gateway is 10.123. R2 is also 10.123. Then how the traffic can reach internet is, it depends upon the HSRP active and standby router. So HSRP routers are two roles, active and standby. So router which is elected as a active, so that router actively forward users traffic to internet. Router which is elected as a standby, that standby is a backup for active. Whenever active is fail or down, it'll take over about active router role and it forward the user's traffic automatically. So this is a mechanism of HSRP, but which one is active and which one is a standby means router with highest HSRP priority. Router HSRP highest priority will be elected as a active. Second highest priority will be elected as a standby. Example, R1 priority is a 150. Now R2 priority is a 180. Then which one is active and which one is a standby?
R2 is active.
Now R2 is active because of highest priority, right? If R2 is active, then R2 actively forward users traffic to internet with 40 Mbps. But already we have 80 Mbps link. So which router you want to make a active router, that router should be configured highest priority. We can configure that priority actually. Now R1 have configured priorities 170. R2 is 165. Then which one is active and which one is a standby?
R1 is active.
Now R1 is
Active.
Standby R1.
R1 is active, R2 is standby. Right. So what is the active router role?
Access the internet.
Active router actively forwards users traffic. When the traffic is LAN users traffic is coming, so this LAN users traffic to forward internet, active router will take care about it. So means traffic is going by active router. Whenever active is down, then standby router will become active and forward users traffic. Okay, so this is how exactly HSRP protocol works.
But 1 second, when you go back to that figure, Balu, here, say for example, you're telling that R1 is down, but my ISP link is up, right? Meaning I have that 80 Mbps link which is going waste. So can't we use that?
No, we cannot use that. So we have to go with the secondary because of router 2 is down. Sorry, router 1 is down, then traffic has to go on router 1, router 2.
Both the ISPs cannot be clubbed virtually and there's
Of
nothing
course,
like that.
we can use the load balancing also here. Yeah, that is what FHRP protocols are 3 protocol: HSRP, ERRP, and GLBP. HSRP is a Cisco proprietary protocol which will provide default gateway redundancy, no load balancing.
Okay.
So HSRP will work in only active and standby model. So means only active router only forward the traffic. So one router, one ISP is wasting here actually. Whenever
Yes.
this is down, then only can go with another one. So means it's providing just redundancy only, backup. Similarly, VRRP also same like HSRP, but the problem point is what? It's open standard. And compared to HSRP, it's faster. But VRRP also don't have a load balancing mechanism. But we can do load balancing in HSRP, VRRP also forcefully. That is secondary point. But there is no inbuilt mechanism of load balancing in HSRP, VRRP. But there's a protocol which is specially designed for it provides a redundancy with the default with the load balancing. Is gateway load balancing protocol means redundancy is available. At the same time, load balancing also means you have a two routers we can use to forward the traffic. Have a 3 routers in the LAN, 3 routers, 3 ISPs we can use to forward the traffic. GLBP. So, but the thing is the GLBP Cisco proprietary protocol.
Then what will be the topology? Same? It will be the same?
Same topology. In GLBP, there are no standby model. Both are active routers. In GLBP, all routers are active. Forwarders. Active forwarders actually.
Active.
Yes. Similarly, active. Forwarders we called in GLBP, not active. Forwarders.
Okay.
Both routers are forwarders. Yeah. So we'll have a complete discussion on VRRP, GLBP, and CCNP level classes. We'll see about HSRP in here now.
One doubt.
Yeah, please.
In GLBP, there is a load balance is there, no?
Yeah.
Load balance is done if only both routers are same Mbps and 8080. Or even the different continue load balance.
Different bandwidth also.
Okay.
Not to be the same bandwidth, different bandwidth also.
Even in different bandwidth.
So router 1 traffic is 80 Mbps, router 2 is 40 Mbps. So some traffic will go with the 40 Mbps users. Some traffic will go to 80 Mbps. Yeah, we can segregate the network actually, So some very high active team is there. So that active team will use 80 Mbps. So maybe second grade team will go with the 40 Mbps. Like we can segregate that actually. We can give the priority for traffic. Yeah. So HSRP groups multiple physical routers into single virtual router, and these devices can share virtual IP and MAC address information. Routers which are grouped together means these two routers are grouped together, right? For this group, you have to define the group number. That number should be same on both routers. Must be assigned the same group number. Group number range is 0 to 55. So when a router is down or link fails, this is a second physical device ready to respond to the same default gateway address information. So R1 has 10.0.0.123. R2 also is available 10.0.0.123 information. So if R1 down, so R2 will be take over that. So in this topology, try to find out and tell me which one is active and which one is a standby. Yes. So we can't say because of we don't know priority values of R1, R2, right? Now I have defined the priority values. Then which one is active?
R1.
R1.
One is
R2 is
active.
standby.
Okay. So active router role is actively forward users traffic. Whenever active is down, then what is the next step?
R2 is
To take.
Standby will become active and forward users traffic, right?
yes.
Yeah. But what you people understanding here is, what you need to be understand, if active is down, how standby knows about active is down? How standby router knows about active is down? It has to become active router, right? So that how R2 knows about R1 is down? Yeah, that is the mechanism of HSRP. You know what HSRP we're doing is, how HSRP works. When you have enabled HSRP in R1, in R2, R1, R2 will send hello packets for every 3 seconds. So they used to exchange hellos for every 3 seconds. Inside the hello, virtual IP address and priority values, MAC address, this information is there extra. So in network, R1, R2 for every 3 seconds, they exchange hello packets. It's a keep alive mechanism. Now R1 will send hello to R2. R1 will send hello to what? R2. Now what R2 will think? So my priority is 150, but R1 is the highest priority, then I'll become standby. Then R1 will think about it, what, yo, my priority is 200, your priority is 150 only. So I have a highest priority, I'll become active and it's forwarding users traffic. So every 3 seconds exchanging hellos. Now suddenly R1 fails. If R1 fails, R1 will send hello to R2. No hellos. So whenever there is no hellos, then router 2 will wait for 10 seconds, just 10 seconds. up to 10 seconds, if there is no hellos, then standby router will take the role of active and forward users traffic. Automatically happen actually. So whenever standby will not receive hellos, it become active. So means if any one router is down your network, LAN users to reach internet, how much time will take?
10 seconds.
It's just a 10 seconds without any knowledge of LAN users. So your LAN users, they don't know anything actually. So I am getting internet with the R1 or R1 fails. Now I'm getting internet with R2. They don't know anything. Without any knowledge, they are reaching internet. But in the back end, we are the team. The network team is going to configure router 1, router 2, HSRP, VRRP, standby, active, virtual IP. This everything is been managed by our network team. We're just providing the proper internet services for your customers, your LAN users.
But how about DHCP then? If your R1 is a DHCP server, again, even that is going to be the standby mode.
No standby. If our active is down, then no standby.
Then how about the IP address to the computers there in the LAN?
In both sides, in R1 and R2 need to be configured DHCP. If R1 fails, we'll get IP from R2. Yeah.
Sir,
Yes.
there is R1, R2, and one router is R3. So R1 is down. So then which one is active? R2 or R3? If there is 3 routers.
Yeah. In
It means
HSRP,
priority next to level.
yes.
Which one is high priority?
No, in HSRP, we cannot use the 3 routers. It should be 2 routers only HSRP.
Okay, thank you.
Active and standby model. But we can have multiple backup, multiple standby routers in VRRP is possible.
Yeah.
HSRP works in
2 routers.
active and standby. That's 2 roles only. What if I have a 3 routers? One is active. So 2 routers cannot be standby. One active, one standby in HSRP. But in VRRP, it can possible 3 routers. So one is in master and one more is in backup. So if master is down, out of 2 again, which is the second highest priority, that will become the master. Okay.
In HSRP, is possible to give same priority for 2 routers?
Yes. If priority is the same for all 2 routers, then which will become active is the router which becomes up first. That is active router. Yeah, here the high point is it. If the priorities are the same, first router up becomes the primary. So which router ups first initially, that will be the primary. Means that is active. The default priority is 100. Default hold time is 10 seconds and hello timer is 3 seconds. Router with highest priority will be active and second highest priority will be standby. And HSRP election process, it use multicast messages, means hello packets with 224.0.0.2 as multicast IP address. Do you remember all protocols multicast IP addresses? RIP multicast address, remember?
5.
9.
9 is okay. OSP 9, I think, right?
Yeah, OSP is 5, RIP is 9.
Okay, I told the opposite. Okay.
EIGRP,
Same 5, 9.
yeah, RIP is 9, EIGRP is just 10. So HSRP is 2, VRRP is 12. Like these multicast addresses have to be remembered actually. Okay. Yeah. I'll see now configuration part, how to configure and how to make this R1 is active and standby model. Yeah. R1 and R2, two routers. Already configurations is there. Let me make this default configurations. Yeah. Now LAN interface R1 fast Ethernet, R2 fast Ethernet the shutdown is not inactive. We'll configure physical IP, virtual IP, all those things. Interface fast Ethernet 0/0 IP address 10.0.0.1 250. Says physical interface IP address. Now virtual IP need to be configured. Standby. Now we are grouping two routers. So that group number should be same in both routers, right? So standby group number 0 to 55 can use any number. My example group number 3. Standby 3. IP space virtual IP address 10.0.0.0.123 or example. Standby, if you want to make R1 is active router, then you can configure highest priority. For standby, group number 3, priority. In our examples, 170, 170, 170 is the R1 priority. Yeah, this is the configuration. So we have assigned physical interface IP, virtual interface, virtual router IP, and priority. Let me configure in router 2.
But where are we telling it is HSRP?
Standby means HSRP. Command itself, standby IP, this is a HSRP configuration.
Okay.
So HRP syntax configuration is this. Yeah, standby HSRP group number. Like this, okay? In router 2, physical interface IPs 10.0.0.2, 255.0.0.0. Standby, same group number 3, IP space, virtual IP, standby, group number 3, priority, 165. So R1 priority is 170, R2 priority is 165. Yeah, let me make the no shutdown in the both sides. No shutdown command. Both are in shutdown state. Let me enter no shutdown in R1, in R2 also. Now they'll start exchanging hello packets, and hello packets has been comparing. So my priority is 170, your priority is 165. So have highest priority, and what is your virtual IP address, my virtual IP address, both are same. Yeah, elections is going on now between R1 and R2. So once if elections is done, then show IP, show standby brief. Still elections is going on. Let me save the configuration on both sides. And let me do re-elections once again. I just restarted the switch. Now all devices have been reloading now. Now we'll get exactly proper outputs. Show standby brief. So interface is fast Ethernet. Group is 3. Priority is 170. State is speaking state. Speaking to standby to active. So elections is done. Now router 1 is selected as a active is local, and is electing a standby also. Still is electing a port standby. It is showing the unknown. Yeah. Elections is done. Router 1 is active. Standby is router 2, which is 10.2. Virtual IP is also. Highest priority, because of its highest priority, it's active. And router 2 verification. Router 2 show standby brief. State is standby. Active is 10.1. Standby is local router. Okay. Now, whenever active is down, let me make active is down. Active is down. A standby router will become active. Router to wait for 10 seconds. After that is not receiving hellos. Router 2 state is active. Priority is 165. Now no standby. Standby is unknown now. Okay. So like this, we can understand HSRP behavior, how it's providing a redundancy for gateways, router redundancy protocol. Clear? Any doubts? Right, we'll see the next scenario. R1, R2, R3. R2 is our target. R2 LAN is our target. 192.168.2.1 network. So we have a laser lines between R1 to R2, R2 to R3, R1 to R3 also, backup. So one laser line from R1 towards R2 is via S00. The one more laser line from R1 to R3 S01. Right. So now my question is here, from R1, how we can reach to R2? Need to be configure routing protocol. Which routing do you recommend? The small network, 3 routers only. So network is small, then which routing do you recommend? OSPF or RIP or static? Which is the best for small networks?
RIP.
Static.
Static. Okay. Now towards R2 LAN, how to configure static routing? Just tell me configuration. From R1, how to configure static to reach R2? IP route, destination network ID, destination subnet mask, exit, the best exit interface, right? So what is the destination now? 2.0. Subnet mask 255.255.250. And which is the best exit? 0001. Serial 0/0. Okay. Now if we configure this command, then traffic will reach via S00 to reach 2.0 network. Have configured and network is up, everything is going up and running now, traffic is going like this. Now what if S00 is link is down? If link is down S00, the R1 users can reach internet? What do you say?
No.
Why?
Because the link is down.
So your link is down, then how we can reach internet? How we can reach to R2 LAN? No, not reachable. Then again, what we need to do? Again, have to be reconfigured. Now traffic has to go via 0/1. Then traffic can go via 0/1 until unless no. So if we configure exit point is 0/1, then no traffic is going via 0/1. Right? Yeah, I have configured 0/1. Now traffic is going via 0/1. Now what again if your 0/0 is been back again? Your best to
You have to configure.
Again, manually, we should bring it up.
yeah. Again have to be configured 0/0 traffic. Now traffic is going 0/0. If it is again down, then again need to be configured now.
Manually, it should be changed.
Yeah, this is a problem in
Static.
static.
In RIP,
Because-
there is half count.
Yeah.
A small network we can use RIP.
But RIP static is recommended now. Why RIP? RIP utilizes the more bandwidth. It does not consider bandwidth. It's periodical updates, slow conversions. So static is best. So here configure static. But what's the problem in static is if it's down again have to be manually reconfigure. That is the problem. Static. Can I configure like these guys? Yeah. In R1, can execute 2 commands to reach the same destination 2.0. Can I configure like this?
No. First,
If we configure like this, then how traffic can reach to R2? So if we configure static means both is the best. Now traffic will go via both. Means S001 packet, S011 packet, load balancing. Again the problem. Why? 00 is the shortest, best route. No delay. But 0/1 we have the more delay will be there. Unreliable communication. So there's a problem when you have a two, if you write the 2 routes. Yes. Tell me one thing. In one router, I configured RIP, I configured OSPF, I'm running EAGRP also. So in one router, 3 routing protocols is configured. Which routing protocol will work here? Which one works? RIP or OSPF or EAGRP when we have a multiple routing protocols in one router? It depends upon administrative distance. AD. RIP AD is 120, OSPF 110, EAGRP 90. So which protocol works here? Lesser administrative distance, higher the priority, least steady value. So EAGRP works. So when administrative distance will come in the picture, when there is more than one protocol in the router, which protocol has the priority, for that AD value will be there. Reliability of the protocol. All right?
yes.
Yeah. So now my question is here, the same thing. I have configured 2 static routes. 2 commands I have configured. 2 commands is running. 0001 to reach the same destination. 2 static routes. What is the AD value of static route?
1.
1. Second one is also 1. both are same, then both statements will be work, load balancing. If there is a load balancing problem, unreliable communication. So what we are doing here it is, which is your primary link and which is your secondary link, find out first. If 0, 0 is your primary link, then let's keep the same AD value. If 0/1 is a secondary link, then configure higher AD value than primary root. So primary root AD value is 1 and secondary root 0/1 AD value is 10 I have configured. Now two commands in there in your router. One is AD value is 1, one is AD value is 10. Then which command will work here? Which statement will work?
1, the first one.
The first one. So mean traffic is going where? 0/1. Whenever 0/1 down,
0/0.
automatically will go the traffic with 0/1.
Wow, okay, this is a very good thought. Yeah.
So this type of routing we call floating static route. So a static route should be flow. Floating static route. So in static routing also we can have the redundancy backup. So we just configure the administrative distance, higher administrative distance in primary route. So this floating static route we use when your primary route is not available to provide the backup. So floating static route is configured with a higher administrative distance than primary route. Okay.
This is a good feature.
Yeah, in static also we'll do like a dynamic protocols by configuring of these things actually. We'll see the practically how it works. Three directly connected networks and my destination is 2.0. IP route 192.168.2.0, 255.255.25.0, serial 0/0. It's my primary route. AD value is 1. I'm keeping. No need to be configured. Default is 1. Just for understanding, I have configured 1. Next route is 0/1 for the same destination and AD value is 5. Something 5 or 10, whatever. 5 I have configured. Now, which statement will be come in your routing table?
1.
In routing. The least AD value command will come, right? Lesser AD value, higher the priority. So now if we check the routing table entry, we have static routing is there. 2.0 you can reach statically with which interface? S00. Now traffic is going by S0/0. Whenever S0/0 is down, then immediately without any delay, still we can reach 2.0 with S01. So before static is 2.0, we can reach with S00. Now after your 00 is down, then immediately without no delay, so we can reach to 2.0 with 0/1. If it is a dynamic routing protocol compared to dynamic, if any link is down, there is some algorithm is there now. Like it has to be update, hellos be not received. It will take some time, processing time. But static routing, in floating static routing, whenever if link is down, no hello mechanisms, nothing, no algorithm. If link is down, come into another path. Fast. That is why we call static routes are faster, reliable, secure.
Then in the previous example, when we had two ISPs, one with 80 Mbps, other with 40 Mbps, both can be connected to one router only.
Yeah.
And enable this one so that we have redundancy on the ISP part.
Yes. Exactly. But we need to be configured default static routing in there. Not the static routing. Means IP route 000, AD value is 1. Again, IP route 00, AD value is 10. So ISP 1 you can make the primary is 80 Mbps. Whenever ISP 1 is down, we'll go with ISP 2 automatically.
Yes, okay.
Yeah, that is default floating static route. Default floating static route. Okay. Again, your link is been back. Serial 00. As long as your serial port become up, yeah. Now again the traffic is going back to 00. Means your ISP1 become up again. So you will reach internet with 80 Mbps again back automatically. Okay.
Balu, can you also maybe take out some time whenever you are, how are we prioritizing the packet? Meaning which packet should go with a higher weightage and which one probably has a lower weightage? Is
Yeah,
it on the
that
protocol?
no, it's that we need to be configure.
See, as I understand, voice is the given the more priority,
Yeah.
which are real time, which is probably depending on UDP, whereas the data is given a lower priority, is what I understand from the industry.
So that is what we need to be configure QoS.
Quality of service, okay.
So if we configure QoS, then we can define voice traffic has a special flags. So QoS need to configure flags. No, the flag which is a red flag, high priority, and the green flag. Like we can define that flags and priority actually weightage of the data services.
Flags are given to what? Are they given to protocols or given to VLANs or what? What is the priority?
Protocol flags is given to the service, HTTP service
Okay,
and FTP
service, okay.
service.
Okay, okay.
Service. That is what quality of service. Like okay. So floating static route, configuration, IP route, destination ID, mask, exit, number, administrator distance. Okay. All right, guys. So this is all about for today, and tomorrow we'll continue with some more uh, local database authentication and centralized database authentication, and so these things will be seen too. Thanks to all. Have a nice day.
Balu?
Yeah, please.
Up to now, we are doing these configurations or any modifications, CLI means command line interface in routers.
Yeah.
In packet tracing, but in real time, we will configure admin machine through a configure port.
Yeah, in the real time also we used to configure with through LAN. We can configure.
In admin system.
Admin system is a console port.
Okay.
So if we have a privileges, then we can do. But as a junior engineers and the categories wise, we don't have a privileges to get a console directly through telnet, and with some limitations we can get actually.
Mm.
Yeah, means your access should be go with a AAA server. In AAA, we have some limitations. Privilege levels will be there.
Mm.
That is tomorrow we'll discuss about that. How to configure the AAA. Okay. All right. Thanks again. Bye.
Thank you, Balu.
Yeah.